So in this video, I'm going to answer the question, what is the backpropagation algorithm? So the backpropagation algorithm, or just backpropagation, is the algorithm to efficiently calculate the gradient of the loss function for a single weight/bias by the chain rule. Backpropagation is short for the backward propagation of errors. The gradients of the loss function are then used by the optimizer to update the weights and biases of the network. It is important to note that some people use the term backpropagation to refer to the entire backward pass as opposed to just the algorithm. The chain rule of differentiation is shown for the function y that is composed of the outer function f and the inner function g. What the chain rule demonstrates is that we can obtain the derivative of a composite function, which is a function within a function, and in this case y, by multiplying derivatives of the inner and outer functions. We can gain a better understanding about why this is useful in neural networks by considering the case of two layers of single neurons. As usual, the activation of the neuron in the second layer is calculated in two steps. First, by taking the weighted sum of its inputs, and then by applying the activation function to this weighted sum. We choose a loss function, such as the mean squared error, to calculate the loss given the activation and the actual ground truth value, represented here by y. We would like to calculate how to adjust the weight given a certain loss. Backpropagation / the chain rule gives us a way of calculating the derivative of the loss function with respect to the weight through calculating the product of certain intermediate derivatives. This can then be used by an optimizer, such as gradient descent, to update the weight. Similar maths also holds for updating the bias. Now, considering many layers of single neurons, the same maths applies for the weight connecting to the final layer. Through backpropagation / the chain rule, we can also express the derivative of the loss function with respect to the previous weight through the multiplication of intermediate derivatives. We can see that some of these derivatives have been used in the previous calculation. In backpropagation, the reuse of these derivatives reduces the computational overhead required. When layers have multiple neurons, the activation of a neuron can impact the activation of multiple neurons. Therefore, the maths doesn't change much. We would just need to sum multiple terms to take this into account. And so that's all for this video. Thanks for watching.